Here is a pre-calculus question on, what do they call it? Projectile motion. I want projectile motion. Partnering up with Tiger Weeds, that's supposed to be Tiger Woods, is Jordan Spatoon. I guess that's supposed to be Jordan Spieth out of the Dallas area. He hits a shot that goes 280 feet and skims the top of a 120-foot tree at the peak of the ball's path. Use regression and or matrices. Let me zoom in so I have room to write. So I'm going to draw the situation first so that I know what values to use for my regression. It's a parabola, and remember, parabolas are symmetrical. And that's going to come up later. There, oh boy. The launch angle is going to be the same as the angle that it falls to the ground. The launch initial velocity is going to be the same as the final velocity. I guess that's better. So it starts at 0, 0. And then it travels 280 feet, and the height again is 0. And at its peak, it's 120 feet high, so 120. What's the x? Well, it's symmetrical, so it's halfway between. The vertex is halfway between, so it's 140. So now I have 3 points, and I can make a regression. You can use your TI calculator. I'm going to use Desmos. And let me see, I'm going to put table, and I'm going to put my point 0, 0. What was it? 280, 0, and then 140, 120, and I can just press the regression button, or you can make it by hand if you want fractions. I don't need fractions. So there's the equation. Y equals negative y, well, h of t actually, it wants us to call it h of x. I guess they want to use x. H of x equals negative 0.00612245, negative 0.006. I forgot it already. 122, 1, 2, 2, 4, 5, x squared plus 1.71429 plus 1.714. Oh boy. It's run right into my picture. Okay, wait a minute. Let me move the picture. I'll move the picture just a little bit. 1.71429. 1 point, oh boy. Come on. X. Okay, that's easy enough. Write the equation for the golf ball's path using vertex form. Vertex form is h of x or y, whatever you want to say, equals a times x minus h squared plus k, where hk is the vertex. So I know the a, this is equal to negative 0.0612245 x minus 140 squared plus 120. That's the vertex form. What is the angle at which the golf ball takes off? Well, to get the angle of takeoff, I need to know what the slope is right at the beginning. I need the slope. And if I can find the slope, then I'll take the tangent, arctangent of the y component over the x component, and that will give me the angle. Well, okay, how do I find the derivative? I want h prime of 0. So the derivative is, remember the power rule, 2 times that. I'm just going to put something, because watch what happens, and then x, 2 minus 1 is 1. So x plus, this originally was x to the first, 1 times 1.71429. 1 minus 1 is 0, so the x goes away. And now if I want the derivative when x is 0, I plug in 0. So this is something times 0, which is just 0. That goes away, plus 1.71429. So I just take the arctangent of that. Arctangent of 1.71429. And that will be my launch angle. Arctan 1.71429er. 59.7 degrees approximately. Approximately 59.7 degree. Yes. In order to introduce the parameter time into this area, find the time it takes the ball to fall to the ground from its maximum height. Well, the maximum height is 120, so this is and it falls, it goes down, so it's negative 120, gives the formula here, equals negative 16 t squared. So t squared equals negative 120 over negative 16, and if I take the square root of both sides, I get t equals the square root of negative 120 over negative 16. So t equals square root, I can drop the negative signs because a negative over a negative is a positive. 120, it better be positive because I can't take the square root of a negative number. It's actually plus or minus, but 2.7386, approximately 2.7386 seconds. And let's see, let me look at the answer key. Yeah, it always rounds it to 3 decimal places. Approximately 2.739 seconds. Okay, find the ball's speed when it hits the ground. Well, speed is the derivative of height. So v of t, and this is the speed with regard to y. I guess I'm not going to write that because that might be confusing. The speed, there's 2 components to the speed when it hits the ground. It's going to have its y component and its x component, vy and vx. And if I know that angle, if the height angle is 59.7, so is the landing angle, I'll take the arc sine of the landing angle equals the velocity with respect to y, that's this, what I'm about to find, divided by whatever the final velocity is, which is also going to be the same as the initial velocity. So v of t equals, power rule, 2 times negative 16 is negative 32t. Okay. So, v of t equals negative 32. That's the y component, is negative 32 times 2.739. Now you can use the exact value. The answer key uses this interim rounded value, so that's what I'm doing. 32 times 2.739, and that's approximately 87.648. 87.648. Is this feet? Yeah, I guess it's feet per second. Now, how do I find this one? How do I find, that's this. That's the velocity with respect to y. How do I find this, the velocity at that angle? Well, again, it's going to be the sine of 59.7 degrees. And the answer key uses all the rounded values in the interim, so that's what I'm doing. And that's going to equal opposite over hypotenuse. So that's my Vy, 87.648 divided by the velocity, I don't know, you can call it the velocity final, which is also the same as the initial velocity. Okay, so if I multiply both sides by velocity final, divide by sine 59 by 7, 59.7, the final velocity equals 87.648 feet per second divided by sine of 59.7-ish degrees. And if I do that, 87.648 divided by sine 59.7 degrees, and I'm only using these rounded values. Like normally, I wouldn't use, if I were doing this, I wouldn't use sine of 59.7. I would use sine of arctangent 1.71429, or arctangent, yeah, arctangent 1.71429. But the answer key uses these rounded values. So that comes out to 101.5. For some reason, they only went 1 decimal place on this one, 101.5 feet per second. Okay, now parametric equation that incorporates time and relates parameter to the distance and height that the ball travels. I don't know why it repeated that twice. It's taking up my space. Well, the parametric equations are these. And by the way, this is V0. It's also the v final. It's both. Because remember, again, symmetrical. So this is v0. It's also the velocity of the time, which is double that, or v final. So it's the same. All right, v0 cosine theta t. So this is going to be 101.5. This is the x parameter. 101.5 times cosine of 59.7 times t. And then the y parameter is going to equal 101.5 sine 59, I better put degrees there, 0.7 degrees times t minus, now what is the minus 16t squared? That accounts for the acceleration due to gravity. And what's the h0? h0 is just 0. It starts at 0, so that's why it would be plus 0, plus the h0, but I don't have to write that part. So there's my parametric equations. Whoops. There's my parametric equations. And everything is finished.